Hello, my name is Ali Sekman. I'm a professor of computer science at Tennessee State University. In this video, I'm going to introduce you the inner classes. We'll focus on member inner classes, local inner classes, and anonymous inner classes. It's an important concept. It may seem to be tricky at the first time, but they are pretty easy. Okay, so let's get started. This is Cont 3110 Java programming class, and we'll talk about inner classes today. So far, all the classes that we've seen are top-level classes. For example, they can be public, they can be abstract, they can be final, they may have no access modifiers, but top-level classes cannot be private, protected, or static. What do I mean by that? All the classes that we have seen so far, we have seen public class, abstract class, final class, and just a class without any access identifier. Abstract class means it's a class that's most likely have an abstract method that needs to be implemented by a subclass. Final class means that class cannot be superclass of any other classes. However, if you make your class private and try to compile, you will get an error. If you make it private and try to compile, you get an error. Again, static, you cannot. Top-level classes cannot be private, protected, or static, whereas they can be public, abstract, final, or without any access identifier. So what's a nested class? You can define a class as a member of another class. That's called a nested class, okay? So this is your top-level class, and this is your nested class, okay? So nested classes can access to all of its enclosing class members. Think about a method defining a class. That method can access to all of the data members of the enclosing class, including private, right? So similarly, a nested class can access to all of its enclosing class members. That includes private. A nested class can be static and non-static, similar to methods. Methods can be static or non-static. If a nested class is static, it is called just like that, a static nested class. However, a non-static nested class has a special name, which is an inner class, okay? Static is static nested class, non-static is an inner class. Okay, so static versus non-static. I'm gonna remind you in the next slide, but static data members are associated with the class, and non-static data members are associated with what? Objects. Therefore, static nested classes are associated with the top-level class. However, inner class are associated with what? Objects of the top-level class. Let's remind ourselves, static versus non-static. Think about this class, my math class, which has something called pi 3.14. This is non-static, as you see here. So if I create 3 objects of my math class, I will have 3 copies of pi, because obj1 will point to a memory space in which I have a pi, obj2 will have a pi, obj3 will have a pi. Okay, so is this making sense to you? Why do I have 3 copies of pi, even though pi is not expected to change, right? It's always 3.14. And the solution to that is to make pi static. If you make pi static, no matter how many objects that you create, as long as this is static, you will always have a single copy of pi. Even if you don't have any objects, if you don't have any one of those objects, you will still have a single copy of pi, which is associated with what? My math class. As soon as this class is loaded, regardless of the objects that we create, we will have a copy of pi. Okay? All right, so non-static variables are associated with objects. Objects are instances of classes. Therefore, non-static variables are also called instance variables. It will be more clear in the next slide. However, static variables are associated with classes, and therefore static variables are also called class variables. Here is a better example. I have a dummy class which has 2 non-static and 1 static data members. And I create 3 objects. Each object will have a copy of non-static data members, x and y, x and y, x and y. Okay? but we will have a single copy of Z, and it's associated with what? With the class. So let's come here and let's do some brainstorming here. First of all, I have obj1, obj2, obj3. I have copies of X and Y's, and I have Z. Now my question is this. Is this okay? Can I say obj1.x is equal to 55? Sure. Go to the memory space where obj1 points to, change X to 55. As you see, it's right there. Similarly, go to the memory space where obj1 points to and change it to what? 67. So that's also okay. And that means this is okay. This is okay. Obviously, these are also okay because there's no confusion. When I say X, go to the memory space, obj points to, and change that one, or change this one. However, when I say dummy class.x, then there's a problem here. What's the problem? Because we have 3 copies of X's. So which X? Java is going to get confused, and this will not be possible. Okay. So since there are multiple copies of X, Java gets confused which X to refer with dummy class.x88. Therefore, this is an error. And this is crucial. Non-static variables can only be referred with object names. As you see, if I want to refer to non-static variables, I can do it only with what? Object names. However, I cannot do it with class name. Okay. Let's go to this example again. Now I'm trying to change Z. Is this okay? Can I say dummy class.z 50? Sure, because there's only one Z. There is nothing to get confused. How about obj1, obj2, obj3.z? Well, still, since there is one Z, I can refer to it any way I want. There is no confusion. So this will be okay, this will be okay, this will be okay. All right? Since there's only a single copy of Z, Java does not get confused no matter how you refer to Z. Therefore, static variables can be referred with object names or class names. Okay, so just you need to feel very comfortable with those things. You can refer with class name, or you can refer with what? Object name. All right, so of course we don't have just static data members. Method may be static or non-static. So I'm going to come here. I have obj.x. Well, you tell me X is non-static. I'm referring with object name. So this is perfectly okay. Method 1 is non-static. I'm referring with object name. That's perfectly okay. X is non-static. I cannot refer with class name, right? Non-static cannot be referred with class name. Similarly, method 1 is non-static. So I cannot refer with class name. However, this is okay. Z is static. Static can be referred with object name. Static can be referred with class name. And method 2 is static. And it can be referred with what? Of course, class name. So I hope you feel comfortable with this. Okay, remember, can we call a non-static method from a static method directly? This is what I'm asking. I have main method static. I have display non-static. My question is, can I do this call directly? I cannot. And the reason for that is that main is static. That means I can call main without any need of object of test class. Assume I do that. Assume I call main, and then I will come to this line, and I make a call to display method. But display is non-static. That means display will require somehow an object of test class. But I don't have an object of test class. So that's a contradiction. Okay, and you will see the statement here. Non-static method cannot be referenced from a static context. Here, what is the static context here? It is this method right here. This is the static context here. So this static context cannot refer to a non-static method. Okay, so what do? First, we create an object of test class and then call. Now we can come back to discussion of static nested classes. Always think about a static method when I compare static nested class to non-static nested class, which is inner class. Static nested class cannot refer directly to instance variables or methods. When I say instance variables, that means non-static data or non-static methods. Just like a static method cannot call non-static method, a static nested class cannot refer directly to what? Non-static methods. Okay, for example, here I have a static nested class and I have a non-static method. I'm trying to call it directly. that will be an error, okay? Because I have a static context here. What is the static context? Here. Remember the error we get? A static context cannot refer to non-static methods. So you're gonna get, again, the static context here is the whole class here. So how do I fix this? Well, method is a method of this class, outer class. First, in order to call this method, first I need an object of this class. Then I can make a call to method. Okay. Then this will be perfectly okay. So how do I create an object of this non-inner class? When I say non-inner, inner is static, non-static. So static, I just call it non-inner. I mean, it's just it's not a good name, but I just name it that way. So how can I create an object of static nested class? Static nested class are associated with top level class, right? All you have to do is use top level class name, and then static nested class name, top level class name, static nested class name, okay? Okay, don't get confused. If you want to create an object of top level class, you say top level class, object name, new top level class. But this is not what I'm trying to do. I'm trying to create an object of this class. Top level class dot the name of the class, top level class dot the name of the class. That's pretty simple. Okay, a static method can be public, private, protected, final, or abstract, right? Just similar to that, static nested class can be public, private, protected, final, or abstract, or no access identifier. So now let's talk about inner classes. From this point on, it's crucial. They are non-static nested classes. Inner classes are nested classes, but they're non-static, okay? Here, this is my top level class. This is the constructor of top level class. And this is my inner class, and this is the constructor of my inner class. So this is top level class. This is constructor of top level class. This is my inner class. And this is constructor of inner class. Okay. So there are 3 types, and each type is very important. We'll talk about member classes, member inner classes, local inner classes, and anonymous inner classes. Member classes are just like, you know, data members, a class defined within another class. Local inner classes, think about local members, local data. What does it mean? Or local variables. Variables defined in a method or in a constructor, right? Similarly, you can define inner classes within a method, within a constructor, and so on. They are called local classes, local inner classes. Anonymous inner classes are a little bit more tricky, and we'll talk about it. So now let's go and discuss the first one, member classes, okay? Now, this is top level class, this is inner class. As you see, it is non-static. And if this was static class, then this would be how we create an object, right? Top level class, then inner class name, top level class, inner class name. However, this is an error. The reason for that, in order to create an object of inner class, first we need an object of top level class, because non-static are associated with objects. Therefore, I will need an object of what? Top level class first in order to do this. As you see here, this will be an error. However, what do? First, I create an object of top level class. Then I create an object of inner class via what? This object here. Okay, so top.inner, and then you need what? Object of top level class. This is important, okay? That's what you need. And then this will be okay. Or another way, this will look a weird notation to you, but it is pretty simple here. And then I have this. This is what? An object of top level class. I didn't give a name temp because I will never use temp anymore. So I'm just gonna create an object of top level class without a name, and then via that object, create an object of the inner class. Similar to this. First, I have temp, and then that new inner class. But since I'm not gonna use temp anywhere, I just replace temp with what? This one. Okay. This is what you do. First, create a top level object, and then make a call, and then use the new keyword to create an inner class object. Okay. Well, a non-static method cannot have static members. Okay, this is just a class. This is a method. In a non-static method, can you have a static data member? Makes no sense, because the scope of this X is within this left and right braces. So making it static makes no sense, because static is supposed to exist throughout the program. So this contradicts with the idea of having a local variable X. So therefore you cannot do it. Okay? Here you will get an error. Similarly, an inner class cannot define any static members, since it is associated with an instance or an object. Just like here, you have an inner class, you cannot define a static data member, with an exception, okay? With an exception, if that static data member is final, that's called compile time constant, and you will be fine. So you can have a static data member within an inner class only if it is what? Final. That means if you define it, you initialize it, no one can change it. Then you can define it, okay? These are little tricky concepts, but you must feel comfortable with them. Okay, so now we are in this second one. What do I mean by second one? So we are right now in this local classes concept. Okay. Local classes, local inner classes are defined inside a method, a constructor, and so they must be defined in a block. You may even, if you define it in a for loop, that will be a block, right? So anything that's declared inside a block is what? A local inner class. And it is similar to the use of local variables. A local variable cannot be public, protected, or public. Now you cannot have access identifiers. Why? Because it makes no sense, because a local variable is accessible only within that method. Making it public makes no sense, because no one else can access anyway. Similarly, local inner classes cannot have public, private, protected modifiers. Okay? And local variables cannot be static, right? Similarly, a local inner class cannot be static either. So you cannot have a static nested class within a method. Okay? Now, just to remind you, if I have a method, I cannot have X private, Y protected, Z public, or W static. It makes no sense, because the scope of all of them is within this method. Making private, I mean, it's nice private anyway within this method, and so on. This is, Java does not allow that. Similarly, okay, here is what I mean by local inner class. I have a top level class, I have a local context, and I define my local inner class. So this is my top level class, and this is my local context. Okay, it can be a construct, it may be something else, and this is my local inner class. Okay. Well, think about a method. A method can access all the data members of its enclosing class. Similarly, a local inner class can access all the methods and data members of its enclosing class. But there's a trick here. They can only access final modifiers declared inside a method. Let's check this one. This is going to be very similar to the discussion of local members. Now, this is my top level class. This is my method. And then this is my local inner class. Okay, let's see. These are the data members of what? Enclosing class. What is the enclosing class for local inner? Top level class. Okay, so local inner, inside local inner, you can access to I and D, whether private or not, doesn't matter. You can access to I and D. Anything in the local context, in the global context can be accessed. Okay, now here you have these two local data members. One is final, and then you have input arguments. One is regular, the other one is final. What does final input argument mean? This means within method, you cannot change the value of y to something else. Okay, so the local inner class can access to final data of the enclosing method. For example, this B is final. You will be what? Fine. Y is final. You will be fine. But A is not final. X is not final, so you cannot access to that. Okay. So now we are in the third one. What do I mean by third? We are right now here. This is a fun part of this lecture. It's beautiful. I really like anonymous inner classes. Let's go. It's a very useful but a little confusing concept. Anonymous inner classes are subclasses of an anonymous inner class is a subclass of another class or implementation of an interface, but not both. Can refer variables of the enclosing class, can refer final local variables of the enclosing block, just like the previous slide. And we will see the context will determine whether the anonymous class is static or not, but we never use the static keyword. So let's see. What does this mean? I mean, this looks a little weird, but let's check this slide. Please stop the video at this point and spend a little bit of time to understand what I am trying to do here, okay? So I have a class 1, as you see here. Class 1 has a method called method1. It simply prints hello. I have an interface, interface1, which is a method, method2. As you recall, this is by default public and it is static, public, static, and abstract. Sorry, public and abstract, not static. This method2 is public and abstract, okay? And then I have class 2, which extends class 1. Class 1 is superclass of class 2. And class 2 overrides method 1. See, the same signature, and then the same return type, the same access identifier, and the way it overrides, that instead of it prints hello, it's gonna print what? Hi. And then class 3 implements interface 1. When I say implements interface 1, I guarantee that I'm gonna implement method 2. And I do. See, the same signature, the same return type, the same access identifier. Remember, even if there's no access identifier here, Java will place public for us. So this must be public here. Okay, and it prints, how are you? Now, look here. I have another class test, which has a method called method 3. What does method 3 return? A class 1 object. So method 3 will return a class 1 object. Well, what do? I create a class 2 object and I return it. Is that an error? You see, method 3 is supposed to return a class 1 object, but I'm returning a class 2 object. That's okay because class 2 extends class 1. A graduate student is a student. A Honda is a car. A class 2 object is a class 1 object. Therefore, when I return class 2 object, I'm returning a class 1 object as well. So this is perfectly okay. Now, method 3 returns an interface 1 object. But I am creating a class 3 object and I'm returning it. Is that okay? Yes, because class 3 inherits from interface 1. Interface 1, remember, it's nothing but an abstract class. Simply, it's a class. So class 3 inherits from interface 1. A subclass object is a superclass object. Therefore, class 3 is an interface 1 object. So method 4 returns interface 1. This is perfectly okay. But is there a better way to do this? Okay. Now I'm going to show next slide, which is pretty much the same, but let's see what this does. I have class 1, I have method 1, interface 1, method 2. Now method 3 returns class 1 object, right? Look what I do here. I do something very weird here. Okay, here you go. Okay, let's look at this one. So I'm going to say it. Method 3 will return an object. Method 3 will return an object of a class that doesn't have a name, but extends class 1 and overrides method 1 this way. I repeat, method 3 will return an object of a class that doesn't have a name. An object doesn't have a name either. So the object doesn't have a name, and the class that it belongs to doesn't have a name either. So simply, it will return an object of a class that doesn't have a name, but that extends from class 1 and overrides method 1 of class 1 this way. Okay, don't forget this semicolon right there. I hope you understood this because it's an important concept here. Okay, I repeat, method 3 returns an object of a class that doesn't have a name, but that class extends class 1 and overrides method 1 this way. Since it extends from class 1, that's also a class 1 object. How about this one? I will say it first so that you will understand. Method 4 returns an interface 1 object, right? But with this one, what I say, first of all, you can never create an object of an interface. With this new keyword, I am not creating an object of interface 1. I am creating an object of a class that doesn't have a name, but that implements interface 1 and overrides method 2 of interface 1 this way. Okay, so I return an object of a class that doesn't have a name, but that class implements interface 1 and overrides method 2 this way. Okay, all right, so let's spend a little bit of time. When I say here, new class 1, this doesn't mean an object of class 1. This means create an object of a class that doesn't have a name that extends class 1 and overrides method 1 this way. Here, this doesn't mean that create an object of interface 1. Create an object of a class that doesn't have a name that implements interface 1 and implements method 2 this way. Okay, you can stop the video and think about it a little bit. Okay, we'll come back to that. So a static class can be final. A static class can be abstract, private, protected, public, no problem. Similarly, an inner class can be final, abstract, private, protected, or public, no problem. Okay. How about this? Now I'm going to get a little bit confused, but it is a beautiful concept and you should get very familiar with this. Well, I can have, as you see, I have a class 1, which is abstract. It has method 1. What happens here? Method 3, please stop the video, take a look at it for like a couple of seconds. So method 3 returns a class 1 object. But what do I do here? I say return new class 1. Pay attention with this new class 1. I am not creating an object of class 1, okay? With this one, I'm saying this. Create an object of a class. Create an object of a class that extends class 1 and overrides method 1 this way. In fact, class 1 is abstract, right? I cannot create, if I go and do this, class 1, obj, new class 1. Can I do that? I cannot. Why? Because it's abstract. Abstract classes cannot be instantiated. You cannot create an object. But as I said, here, that's not my intention. This is not my intention. My intention here is to create an object of a class. First of all, that object doesn't have a name, and that class doesn't have a name either. Create an object of an anonymous class that extends class 1 and overrides method 1 this way, or implements method 1 this way. Okay. So now let's see what will be the output of this example. Again, stop the video. These are not that very straightforward examples. Stop the video, spend time. So here I have class 1 and it has method 1. What does it do? It simply prints here 1. Now I have class 2, as you see here, and I have a method called method 2. Method 2 returns a class 1 object, right? In fact, as you see here, this is what I return. But let's see what it is that I'm returning. I'm returning an object without a name, but that object is an object of a class that extends class 1 and overrides method 1 this way. Okay? So I'm returning an object of a class, an object of an anonymous class that doesn't have a name, that extends class 1 and overrides method 1 this way. Okay, let's keep this one in mind and let's see what's happening here. First of all, obj1 will point somewhere in the memory. Is that right? But what did I do? First, I have a class 2 object. That means I created an object of class 2. Okay. So even though obj, sorry, there is no, here, it's not obj1, it's obj, points somewhere in the memory. So even though obj is a class 1 reference, actually what do I have in the memory? In the memory I have what? Class 2 object. And I'm making call to method 2 via class 2 object. So I created an unnamed object class 2. Via that unnamed object, I'm making a call to method 2 here. So what does it do? Method 2 is going to return, method 2 is going to return an object. An object of what? A class that doesn't have a name, that extends class 1 and overrides method 1 this way, right? So obj, even though it is class 1 reference, obj is no longer referring to a class 1 object, but it's referring to an object of a class that doesn't have a name, that extends class 1. When I say method 1, it will not make a call to this one because in actual memory, obj is not referring to class 1 object, but it's referring to an anonymous object. That is an object of an anonymous class that extends class 1. Therefore, it's going to make a call to this method 1, and it's going to print here too. It seems tricky, but it is not if you spend a little bit of time. Anonymous inner class cannot be public, protected. There is no such a thing. You cannot have that context anyway. Anonymous classes cannot be abstract, never static. They're always implicitly final. That means they cannot be superclass of another class. I mean, it doesn't have a name anyway. How can you make it a superclass of another class? Okay, let's see what happens here. Again, this time, stop the video, take a look. This is class 1, method 1. This is top level class. I have a method 3. Inside method 3, I am creating, this returns a class 1 object. So I'm creating an object of a class that doesn't have a name, that extends class 1 and overrides method 1 this way. Inside this method 1, can I refer to this X? No. I can only refer to what? Final data members of the enclosing block. In this case, method 3. So Y is okay, because that's final. but X is not okay, right? Okay, this is a beautiful example, but I want to first discuss something very simple with toString methods. So I'm going to show you what does toString method of object class do. All right, so let's take a look at this program. It's a very simple program. I created a dummy class called car. I have test, and I create an object of car class, and I say system.out.println and obj.toString. First, let me remind you, all the classes are derived from the mother of classes, which is called objects. For example, even if you don't have this keyword here, object, Java is going to go and put extends object for you, okay? So that means class car really implicitly extends from object class. If you put it, nothing is going to change for you. An object class has 11 methods. One of them is called toString. So when I say obj.toString, obviously I don't have a toString method defined here, so it's going to go and make a call to toString methods of what? Object class. So what does it print? Let's go ahead and run this. I'm going to save this. I'm going to bring a terminal, okay? And then here, let's clear, let's compile Java C test.java. Once I do that, Java is going to create two class files for me. One is test.class, the other one is car.class, obviously. As you see, it should come here, car.class, test.class. Now I'm going to run it, and let's see what it's going to print. It prints car at some hexadecimal number. What it prints is obj is going to be, when I say new keyword, Java is going to allocate memory space and refer to that memory space with obj. I told you before that obj holds the address of the memory space. So when I say toString is going to print that memory address and the type of the class, okay? That's what it is going to print. What if I don't have all toString method at all? Java is smart enough that say I'm trying to print the string representation of object class, obj, string representation of obj. String representation means go and make a call to what? toString method. So it's going to be the same. Of course, this time the memory address will change because it will probably gonna be placed in another memory space. Well, yeah, in the same memory space for this case, okay? So that's what it prints. If I go and overwrite that one, if I say public string, okay, public string toString, and then system, or say return TSU, okay. So when I run this one, okay, let's correct this. This time, it's going to make a call to toString method of what? Car class. It's not going to go to, because I did overwrite what I had in the object class. So I'm going to compile, run again. This time, I see what? TSU. So if you don't have toString method, it will make a call to object class. Okay, now, what if I define, let's say that, what if I go and define a static nested class here? Let's say static class, what should I say? Honda, or no, let's say, I'm just gonna make total nonsense here, animal, okay? So this is also a dummy class. Now, I have top level class, and I have what? I do have my static nested class. So how can I create an object of this static nested class? This is what I'm going to do. Car dot animal obj is equal to near car dot animal. Okay. Now, if I print obj, it's going to, what do you think it's going to print? Let's see. I compile, I run. This time it says car $animal at then memory address. You see, it says car $animal because animal is associated with what? First, car class. Okay, so I hope you understand that. Yeah, so I'm gonna go back to the lecture notes right now. Okay, so let's go back to the notes, and here I have interface iRobot, which has a method and it returns a string. And as you know, all the methods are public abstract. Now I have a class called robot4, and I have the main method, and I say println, and I want to print something. I want to print here an object. When I try to print an object, what does Java do? It makes a call to toString method of object class, unless I have overridden toString method. But here, this is going to first create an object of a class that doesn't have a name that implements iRobot this way. So basically here, I will have an object, and that object will have some memory space occupied. But the class doesn't have a name, right? In the previous example, I said car and animal, so it was car $animal. But this time, the class doesn't have a name, it's an anonymous class. So I'm creating an object of a class of an anonymous class that doesn't have a name that implements iRobot this way. So when I run this, I will still see a memory address, hexadecimal number. I will see robot4, $, but since I don't have any name, Java is gonna go and put 1 for me, for the first anonymous class. Okay, so that's what I'm seeing right there. The same thing here. This time I have a method which returns a double. Stop the video and take a look. Here, what does it do? Again, right here, I'm returning an object of an anonymous class that doesn't have a name, that implements iRobot, and it implements method of iRobot this way. Am I calling method? No, I'm just trying to print the string representation of that object. That means make a call to toString method. Again, it will have a memory address, and it will have robot4, and then $1. Okay. If I have another system.out.println somewhere here, this time it will be robot4 $2, because this was 1, the other one will be what? 2. Now, okay, now we will see if you fully understood so far what we have discussed. Stop the video, take a look at it. Okay. Again, I'll buy you a lunch if you can explain to me fully. All right, so I have an interface that has a method which doesn't return anything. Now I have main method, and BOM, I have this statement here. What is that? That means create an object of a class that doesn't have a name, but that class implements iRobot, and it implements method of iRobot this way, and call that method. Okay, I repeat, create an anonymous object of an anonymous class that extends or that implements interface iRobot. That means it overrides method this way and call the method. So it's going to print here, obviously. Okay. If I did not call this method, it will print something like this: robot for $1 at some hexadecimal number memory address. But now what do? I create that object first, and then I make a call to method via that object. Since that object overrides, it comes, that object is as an object of a class that overrides method this way. When I call that method, I call this method right here. Okay. Here you go. This is another question. Again, stop the video for a while. And here, interface iRobot, it has two methods, method and toString. Okay. First of all, I must have this public. I must have this public. Why? Because these are by default public. When I implement them, I must use public keyword. So what happens here? Just like before, right there. Sorry, I am creating an object I'm creating an anonymous object of an anonymous class that implements iRobot this way. Okay, I implement and I make a call to that. Okay, and I make a call to that. How about this one? Now, it's okay. Let's go here. All right. Here. Okay, we'll see. We'll see. We'll see if there's a difference between these two. I create an anonymous object of an anonymous class that implements iRobot, and it overrides to string method this way, and it overrides method this way. Okay. Do I call any of those methods? No. And that means I am printing the string representation of it. String representation of it means making a call to toString method of object class, unless I have a toString method defined in my implementation. As you see here, I already have toString method right there. So when I call this, it's going to have here, and it will also have what? Here, this one. So my question to you, here I did not have to implement both of them. But if you recall, I said that if I implement an interface, I guarantee that I'm going to implement all of the abstract methods. Well, here I only implemented methods. I did not implement this one. I would expect that you will question that. In this case, it's not a problem, because when I say I create an object of an anonymous class that implements iRobot, that anonymous class also extends from object class by default. An object class has toString methods, so I didn't have to overwrite that. But here, if I don't have this, think about this. If I don't have this, if I remove it, this is a compile error. Why? Because here I'm saying that I'm going to create an object of an anonymous class that implements iRobot, and it implements only toString, but it didn't implement method. Well, who's going to implement method? Therefore, unless you have this dummy implementation here, you get a compile error. Here, you don't, because you implement method, but toString is implemented where? In the object class. Okay, stop the video for a second and take a look in this. True or false? Let's talk about it. Static nested classes can access all variables and methods in the enclosing scope. Is that true? Static nested classes can access all variables and methods. Remember, we said that static nested classes can access static variables and methods. They cannot access to non-static. From a static method, you cannot call non-static. Similarly, from a static nested class, you cannot refer to what? Non-static data members. Inner classes cannot define any static members unless they are compile time constants. If you remember, I said that in a static inner, in an inner class, you can have static int x equal to 10. You cannot, but you can have static final int x equal to 10. Inner classes can be private, protected, public. Sure, just like methods can be what? Private, protected, public. A top-level class can be static. False. A top-level class cannot be static. It can be only what? Public. It can have, as we listed before, abstract. It can be final, but it cannot be what? Static. A top-level class can be private or protected. No. Local inner class can be static. As I said, local variables doesn't make any sense to have static or non-static. So similarly, you cannot have a static local inner class. Local inner class access all the methods, and what a local inner class can access all the methods and variables of its enclosing class. Yes, but we said that it can only access the final modifiers declared within the method. An anonymous inner class can be a subclass of another class, yes, or it can be what? An implementation of an interface, but it cannot be both. Anonymous inner class can access all variables of its enclosing class, sure. Similarly, but it cannot access to all variables of the method in the method. It can only access to what? final variables in the method. An anonymous inner class can extend an abstract class. Sure. Yeah. Okay. Let's look at this. This is the top level class. I have an inner class. I have static nested class. Okay. So in an inner class, non-static inner class, you can have static only if it is what? Final. But in the static, that the situation is different. Okay. Well, yeah. So let's go here. This is a little bit tricky. So you have a static method. You cannot define static member in it. That's definitely not the case because the scope of this X will be local to this one. However, for a static nested class, you can define a static data member. For a non-static nested class, which is an inner class, you cannot define unless it is a final or compile time constant. Okay, this is the top level class. You have an inner class. The inner class can be abstract, no problem. Okay, so now my question is, this is top level class and inner class. What can I have here to create an object of inner class? First of all, can I have this? Can I have top, inner, top, inner? I cannot. This can be used only when this one is static, if the class is static. So I cannot have that one. Well, can I have this? Top and inner, and I created an OBJ object of top level class? Sure. Using that top level class object, I can create. So second is correct. Third one, you cannot directly access to this without top. Again, you cannot access to this directly. And the last one, let's see the last one. The last one is okay. Why? Because now you go and create a top level object first here, and via that you create an object. So this is perfect, okay. Anonymous inner class cannot have an explicitly declared constructor, and anonymous inner class cannot have a name. That's why that's anonymous, right? Okay, so let's stop the video for a second and let's talk about this. Okay, so I have, these are non-static data members. This is static, okay? Non-static, this is static. So now I have an inner class. This is an inner class. And then I have a method. An inner class can access everything that the enclosing class has. An inner class can access everything that the enclosing class has. So these are all okay. And then here, this is an inner class. Inside an inner class, can I define something static? No, inner class cannot define anything static. So this will be, you having a static method inside an inner class is an error. An inner class can be abstract, no problem. This is static, okay? Static can only access static data. It cannot access non-static I, J, K. That's an error. Just like static method cannot access the static data members. This is static. Again, this method is static, doesn't matter. Static nested class cannot access I, J, K, which are what? Non-static. And we also have something called nested interface. As you can have a nested class, you can also have what? A nested interface. And nested interfaces are implicitly static. Even if you don't put static keyword, they're going to be implicitly static. So how do we extend an inner class? That's interesting. You see, this is top level, and then I have inner class, and this is another top that extends this class. Then you can have another inner that extends inner. This is one way. But here, this another inner, okay, you see that another inner is still associated with what? This top level class. Let's see what it means. I'm not going to spend that much time on the slide. This kind of extra, but stop the video for a second and check it. So I have class top, which is an inner class. Top2 extends. This time top2 extends this guy. How do I do that? Top2 extends top dot and inner, okay? And then top2 constructor is gonna make a call to superclass constructor. That means, what is the superclass here? What's the superclass of top2? An inner, right? So I need to make a call to an inner constructor. Well, in order to be able to call this constructor right here, if I put super keyword, it's not gonna work. I have to have an object of top level class first. Then I can say obj.super. Here, this is an error because Java is gonna go and make a call just like this, super. And then since I don't have a top level object first, I cannot refer to an inner constructor. So I will always need what? An object of the top level constructor, top level object, class, sorry. So this is a little different, but it is very similar. I have a class. This time I have an inner class that extends top dot and inner, okay? And then I have a constructor. Again, I will need what? An object of top level class before I can make a call to superclass constructor, which is an inner constructor. Okay, here, this is, okay, I mean, let's see, we have class test. I have a static nested class, and I have another static nested class that extends this one. So robot extends sensor. And recall the exception handling. Your method, if this is the superclass method, this is the subclass method. Robot is subclass of this one. If your superclass throws an exception, and if that exception is unchecked exception, right, that throws an exception, your method here, that doesn't have to throw anything. Or it can throw runtime exception or one of its subclasses, okay? So this will compile fine, okay? This kind of override is perfectly okay. But let's see how much you really understood object-oriented programming. Stop the video for a second and then we'll move. So I have this one, sensor class. I have robot class that extends sensor. I have method, and I have overwritten methods. So what happens here? I create an object and call it sensor. Sensor is an object. I allocate memory space for it. And then I make a call to sensor.method. Well, which method is going to be called? Of course, it's going to call this method right there, and it's going to throw a runtime exception. So it will compile, but when you run it, it will crash because it throws runtime exception and you don't handle it. So your program is going to crash, okay? How about now? Well, I'm going to do this one. So I create a robot object. Here. And then I make a call to method. It will make a call to this one. This doesn't throw anything, so it's going to print here, no problem. The interesting question is this one. So what happens? First of all, is this okay? Can I say sensor is equal to new robot? Here, I'm creating a robot object and assigning it to sensor. Is that okay? Yes, because a subclass object is a superclass object. A robot is a sensor. A grad student is a student. A Honda is a car. So, but sensor will create an object, right? Sensor, even though it's a sensor reference, actually in the memory, what do I have? I have a robot object, right? So when I say sensor.method, don't get tempted to go to this method. It will go to what? This method. And it will print here. Okay. So it's another example. You may need to stop the video again. We have class sensor. It has method 1, method 2, and I have robot, which has a data member sensor, method 1, method 2. It overrides this method. Oh no, actually this says another method, totally different. But this one is over. Well, sorry, what am I saying? There's no subclass, superclass relationship at all. So this is sensor, it has method 1, method 2. This is robot, method 1, method 2. And then I have this. Let's see. I create an object called robot. Okay, with this one. And robot has a data member sensor. So I have sensor here. Okay, and sensor is initially null. Okay, then I create an object of sensor class. So I have sensor. I allocate memory space, in which this memory space I have something called counter. So counter is 99. Okay, then I say sensor method 1. Well, sensor method 1, it will go to this one, and this 44 will be A. So counter will be 99. Instead of 99, it will change to what? 44. And then I say, robot.method1 sensor. Okay, so I'm going to now go to method 1 right there. Okay, I'm going to go to method 1 right there, and sensor, this guy, will be input to what? Method 1. You see that? And it says sensor of this robot, it was null. Now it will be this. That means this guy is not null anymore. It points to the same memory space right there. Okay, this looks confusing, but it is not. Then I have robot.method2.method2. What does that mean? So I'm going to go to method 2 right here. Okay. Whatever it returns sensor, it returns this object. I'm going to make a call to method 2 via that. This object is a sensor object. Therefore, I need to go and make a call to method 2 of sensor class, and it will return counter, which is 44. So it will print 44. It's a beautiful example. You should check it, spend a little bit of time. Now, almost the same, but I have a little difference. Again, I have robot, I allocated memory space. I have sensor, I allocated memory space, and this is sensor is null. And then I make a call to method 1. Initially counter was 99. When I make a call to method 1 with 44, this is 44, this is 44, so counter changed to what? 44, okay? Very good. Then I say robot.method1 sensor, so I go to method 1, and I send sense and sensor are the same, and that means sen is assigned to sensor, and this sensor is not null anymore, but it points what? This memory space right there. Okay. Then I create a new object called sen. Sen is a new object, and in this one I will have counter 99. It's a brand new object. In fact, I say sen.method1 is 99. I mean, it was 99, but set at 91 again, no problem. Now I say robot.method1 sen. Well, I go to method 1 of robot1, robot, but this time, this guy will be what? This memory space. When I say method 2, it's going to go to this method 2 right there, and it's going to print 99. Okay, so this will print 99. All right, so here is one more example. This time I have a class sensor, which has a static nested class and non-static nested class, which is an inner class. So first of all, can I go and create an object of sonar class like that? Obviously not, I cannot. How about this one? This is static, so I can have sensor.sonar and then sensor.sonar. This is perfectly okay. All right. How about this one? Laser is non-static, right? I cannot do the same way as I do for static, so this will not be okay. However, this is okay. Why? First, I create an object of this class, then I create an object of laser class. This is perfectly okay. Or first I create an object of sensor class, then I create an object of laser class using that object right here. So these two are the same. Obviously, there's no such a thing. There's no such a thing. Okay, so this is a little, obvious example. It says, what can you say about test? Robot is in a package called navigation, and test directly creates an object of robot without importing that package. That tells that test and robot must be in the same package. In other words, test must be in the navigation package as well. So now I'm going to show you inner class in action. I know so far, what the heck, we did that. So what is the real use of it? So I'm going to show you a real use of inner classes. And we are going to create a simple graphical user interface that has a single button and a text box. And when the user clicks on the button, it will display hello there in the text box. But you cannot use any IDE. So the whole code is going to be developed from scratch. Okay? I hope you will enjoy this part. So here, let's see first how we can create a frame just like this. So we are going to create a frame. It will be like that. Okay? It will have a title. It will have a text box, and it will have what? A button. So that's what we're going to do. In order to do that, I'm going to use javax.swing. If you recall, javax.swing is a package that includes a lot of GUI components. So I'm going to use JFrame, JButton, JTextField from what? javax.swing package. Okay. In fact, I'm not using java.awt at this point, but I imported it anyway. So, and then I have the main method. I create an object of myself. You see, obj. With obj, I create an object of myself. And here I will have frame, I will have a button, and I will have a text. And which constructor do I call? Default constructor. So I will go to default constructor. Okay, initially, right here, this is null, this is null, this is null, but when I go here, I create a new frame using JFrame class constructor. What it does, it simply creates a new frame for me with a title. It says inner class in action. And this JFrame will point to this frame right there, okay? Then I'm gonna go and create a button. So I will have a button like this. It will say hello on it. And this guy will point to this button. And then I will have a text field of 15 characters, and this will point to this one. So they are just hanging around. They are flowing around. They are not fixed anywhere. So what do I do with this container? Okay, container, that's why I added AWT. I guess, let's see. Let me stop this video for a second. And I'm gonna show you the definition of container class. As you see, container class is located where? In java.awt package. That's why we imported that package right there. So I'm gonna go back to our presentation. Okay. Okay. So here, let's see, are we in the, okay, we are in the correct place. And okay, now I'm gonna go, as I said, we are creating obj. Obj points somewhere in the memory. I have frame, and then I have button, and I have text. This will point to a frame. This will point to a button, which says say hello. And this has a title, inner class in action, and this will point to a text box, which all float somewhere. So here, this is crucial, container C frame get content. Get content pane is a method of JFrame class. And if you call it via the object frame, C will be, let's use a different color. C will be a pointer to this frame right there. So from this point on, if I want to refer to this frame, I'm going to use C. And then when I say set layout is a method of container class, and it creates a new flow layout. Flow layout that comes from java.awt package, by the way. And that means set the layout type of this frame to flow layout. In flow layout, you place the GUI items from left to right. And when you come to the end of a row, you go to the middle of the second row. Okay, that's called flow layout. Now I say c.add text. That means, well, text box was here, right? Take it and place it to the middle of the first row. Then get the button and place it next to it. Okay, say hello. And then pack it. Pack it means automatically resize the whole frame so that it can hold text box and button in a single row. And then set visible is a method of JFrame, and I'm going to make it visible so that we can see it. And set default close operation, JFrame exit on close. So let's see if you recall everything that we discussed so far. Exit underscore on underscore close. This is all capital, and I'm calling it with class name. That means exit on close must be static because I'm calling it class name. And if you remember, the common convention was if something is capital letters all, it is static and final. So exit on close is nothing but a final static int defined in JFrame class, but we don't remember those integers. So set default close operation to exit on close means if someone goes and clicks on the close button of the frame, everything will be terminated properly. That's all what it is so far. Okay. So when you run this program, you're going to see a nice frame here with inner class in action, say hello and text box. Of course, when you click on this text box, the button, nothing will happen because we didn't do anything in that part. So that's exactly what we're going to do now. So what's an event? An event is an object that describes what happened. For example, when you click on a button or when you press on a return, Java is going to create an object, and that object will know what happened. Event source is the source of the event, such as a button or a text box or scroll bar or a list box and so on. An event handler is a method that will receive an event object and it's going to execute the method upon receiving that object. So Java has a very powerful event handling mechanism, okay? For example, you can click on a button, press on a return, select an item from a list box, and any object that is registered will be notified of that event. For example, if you click on a button and if there is an object who was interested in that event, will be notified, okay? But in order to do that, you have to implement an appropriate interface. That object needs to implement an appropriate interface and should be registered as an event listener. So what does that mean? I know this may look a little confusing to you, but with an example, it will be so easy. Events are classes and they're located in java.awt package. And Swing components can generate many kinds of events. And for example, action event, when you click on a button, it generates an action event. If you pick an item from a list box, it generates item event. Okay, and if you drag something with mouse, it generates mouse event. If you press in a letter, let's say, in the keyboard, it generates key event. And the event listeners are interfaces like action listener, item listener, and so on. So let's see with this example. So I'm going to do this 3 different ways so that if I go and click on say hello, it's going to print hello CH students in the text box, okay? That's what I'm going to try to do. So here, so far, this is the same. This is the same. So far, I have that. that as in the previous example. So when I do that, I will have this frame right there. It will have a text box here, and it will have the button, say hi button, okay? So I guess this is clear. Of course, I will have, oops, the title as well, inner class in action. So now, look here. I say implements action listener. Action listener is under java.aw2.event. So action listener is an interface. Action listener happens to have only one method called action performed. And in action listener interface, action performed is defined as public, abstract, void, action performed, action event E, and then semicolon. So if I say implements action listener, what do I guarantee to do? I guarantee that I'm going to implement all the abstract methods of action listener, which happens to be only one. And here I do implement it. What does it do? It goes, text is this text. It goes and makes a call to set text via text and change the text of text box to what? Hello CS students. So that's my action. Okay, that's the event handling. So if somehow, if I'm able to make a call to action performed, as soon as someone clicks on it, I'm all done. But in order to do that, first this button should register. I need to register. I need to listen for events on this button, And I do it with add action listener. Add action listener is a method of what? JButton class, or one of its superclasses. And it starts listening. And the input is this. What is this? This is the caller of this constructor. This means the caller of this constructor. Who's calling the constructor? OBJ. So OBJ is actually this, okay? So it says, listen for the events on this button. If someone clicks on this button, Java is going to create an action event. And that action event will be sent as input to action performed method, and action performed method will be automatically called for us. So in this case, let's get rid of it. This interface will come with this and those. Then I'm going to start listening for the events on this button. If someone clicks, I will be able to catch it. And then as soon as I catch it, Java is going to actually, as soon as that event happens, Java is going to create an action event, E, and make a call to action performed method, which is an abstract method of what? Action listener interface. Therefore, it's going to change this text to what? Hello, CS students. Okay. So basically, there's one trick here. What does add action listener take as input? It takes an action listener object. So now I said this. This was an object of test class, but test implements action listener. This is the superclass. A subclass object is a superclass object. A grad student is a student. A Honda is a car. So that means a test is an action listener. So if I send this, I'm okay, because this is OBJ. OBJ is an object of test class. An object of test class is also an object of action listener. So add action listener takes what? An action listener object. So second way, okay. Now, everything is the same, but I don't implement action listener here. I don't, okay. So everything is the same, the first, and then I have those, I will have my frame, but this time I defined an inner class. You see, this is the top class, but this is what? Inner class. Okay, so now I define an inner class that implements action listener. Class CS implements action listener. Since CS implements action listener, and action listener is a method called action performed, abstract method, I guarantee to implement action performed. And I do. I say public void action performed, and so on. So now can you tell me that a CS object is an action listener object. A subclass object is a superclass object. When I add action listener to the button, I create a new CS. New CS. Well, add action listener was looking for an action listener object. Since CS is a subclass of action listener, a CS object is an action listener object. So I'm perfectly okay. This time, when the user clicks on the button, Java is going to create an event called action event. That event is E. It's going to make a call to action performed method of CS class. Action performed method of CS class. So it's going to go and change text to hello TSU students. So this is how we do event handling with an inner class. Now I have a better way of doing that. Actually, this is the preferred way. And I hope you will fully understand this. Everything is the same. I have that. This time I say button add action listener. Add action listener. Look here. What do I do here? In this one, I know that add action listener is looking for what? An action listener object. So I create an object of an anonymous class that doesn't have a name, but that implements action listener interface this way. So that means add action listener is taking an action listener object, and action performed method is overridden this way. So whenever someone clicks on button, it's going to generate an action event E, and it's going to make a call to action performed method of the input object. Therefore, it's going to make a call to this guy. So it will do exactly the same thing. So we have seen three different ways of implementing. For event handling with a simple GUI in Java. And I hope you enjoy this video. Inner classes and those concepts seems to be heavy, but they are not. They are pretty easy, pretty powerful, and any good programmer should have a clear understanding of those. And I'll see you in the next video.